Video, we're going to look at the unique factorization domain divisibility theorem. So the claim is that let R be a unique factorization domain and AB be some elements thereof. Consider the following irreducible, or rather the following product of irreducible elements. And we have A is associated with P1 to some exponent K1 and continue like this all the way to Pn to Kn. Then B divides A if and only if B is associated with P1 to some L1, which is a smaller exponent. Continue like this to Pn to Ln, right? Where Li is smaller or equal to Ki for all I in N. Okay, now the proof. So the first implication. Let's do first right to left. If A is equal to some Q times, which follows from the associativity, by the way, that A is indeed equal to some Q times P1 to K1, etc. Now we have our product of irreducible elements. And B is equal to some R times P1 to L1 dot Pn Ln for some invertible, against by definition of being associated, for some invertible QR, which are elements of the underlying set of the ring R. Define C equal to Q times R inverse times P1 K1 minus L1. Continue all the way to Pn Kn minus Ln. But then A is equal to BC, trivially, right? Because these are exactly the missing factors from when we divide A by B. So thus A is equal to B times C, and thus B divides A. So this was quite easy. Now the other implication, the left to right. This will require a little bit more work, but not much more. Alright, consider some C from the underlying set of the unique factorization domain such that A is equal to B times C, because we assume that B divides A, and the following products of irreducible elements. Right, and we have B is associated with Q1 to S1, all the way to Q1 to, to QU to SU. And we have some C associated with R1 to T1, all the way to RV to TV. Alright, the composition of these, so the composition By that composition, we mean simply that we add the appropriate exponent. So perhaps if there is 2 squared here and 2 cubed here, the product will have 2 to 5, right? And any elements that are and any of the factors Ri which are associated with any Qi, we just delete them, we just ignore them. And thus we obtain a new composition like so, and we can write that A is associated with, this is the old product of irreducible elements, but it's also equal to the following product. So this is not equal to, but it is associated with this one, the modified one. So we have Qi S1 prime all the way to Qu Su prime times R1 to T. Well, not quite, because we could have removed some of these elements. So some subsequence, right? So we have some I1 to T I1 all the way to say Ri some W to T I W. Now we know that these are associated with each other, because in unique factorization domains, the irreducible factors of a number are uniquely determined, as the name might suggest, right? And so is the case here. Thus, thus for all I in U, there exists some uniquely given J from the set of integers from 1 to n, such that Qi is associated with Pj, while Si is smaller or equal to Si prime, which is simply Kj, right, from up here, because the factorization is uniquely determined. Altogether then, B is associated with P1 to some L1 Pn to Ln for some Ln non-negative smaller or equal to Ki for each I. And this concludes the proof.